Hello. In this video, we're going to go through the classic prime problem, as I'll call it. Essentially, we're going to write a short program which takes a single integer as input and then outputs if the integer value is a prime or not. This is a pretty cool problem, especially if you want to do some further exploration on it, because there's a lot of neat research about the largest prime. We can't get into it here, but it's very, very interesting, and there's some neat reading to explore. So we're interested mostly in this about problem-solving strategies. Of course, this exercise has been given in the context of a loops exercise, so we know we're going to need to use some loops in this. But I always like to start off thinking about some strategies. One of the things we often do as beginning programmers is we jump right to the program, we just start typing in. And my high school computer science teacher used to give that comment to my parents, and they'd say, Paul needs to sit down and stop and think about what he's doing before he actually tries to do it. I reflect on that comment now and appreciate it so much more. So the first thing we want to talk about is think of how you would do it. Write out some examples. So in this case, we're trying to establish if a number is a prime. So if I write a number down, so say I put the number 4, is this a prime? Well, no, it's not a prime. What about 7? Oh, yep, it's a prime. What about 1? No, it's not a prime. Watch this. 1 is not a prime. A lot of people seem to feel that it is, but in fact 1 is not a prime number. So right now, this is what I would be doing if I was doing this. Is 11 a prime? Yep. What about 43? So now I have to stop and pause because I don't know. Is 43 a prime? So now I want to think about what steps would I go through to figure out if 43 is a prime. Now, sometimes we think of these solutions, and these steps might be really a large number of steps. But remember, once we establish what those steps are, we can tell the computer to do them, and the computer can do them pretty fast. So the question is, how would I figure out if 43 is a prime or not? So let's just put a question mark there for now. When we're thinking of strategies to go through a problem, we want to think of extreme cases. So in this case, is there a maximum prime? Is there a minimum prime? Well, we know the minimum prime, right? The minimum prime is going to be 2. So that's the smallest prime number we have. We want to think about when you need to stop checking. So we're going to develop a step-by-step process to figure out if a number is prime, and we want to do as few checks as possible. Again, for this type of exercise, it's not a big deal because it's not a very large process. But sometimes it becomes very important to your program to minimize the amount of steps you have to take. So I like to think of, in this case, in the case of the prime, do you need to do any additional checking after determine that it is not a prime? And you'll see what I mean by that in a moment. So to help us kind of go through this, what I've done is I pulled up a student's program that they sent in. It doesn't work perfectly right now, but I think this is a good starting point. And we have some kind of some thought points up here. You know, what about the numbers I don't have memorized? So we talked about, well, maybe you can memorize the primes, and if you tell the computer all the primes that you know, it can then just check those. And then we kind of came up with this algorithm. We said, well, if a number is prime, it is only divisible by 1 in itself. So if we essentially check if a number is divisible by all the numbers less than it, if we find one number that divides that inputted number evenly, then we know it's not a prime. And so they've written some code here. So let's take a look. So if we run this, input a number from 1 to 1,000. So let's try 2. Nothing. Okay, let's try this again. Let's try 3. Nothing. Okay. Let's try 11. Oh, it tells us it's a prime a number of times. Now, the first thing that jumps out at me here is that I really only want to know if it's prime once. So let's run this again. Let's put a number that isn't prime. Let's put 12. The number is not prime. Great. Let's put 42. The number is not prime. Okay, so we're just essentially testing these out. So let's see what's happening here. So we take an input using a do-while loop very nicely. And the individual that programmed this wanted to only let the user input a number between 1 and 1,000. And for the case of this exercise, we'll leave that to be your prerogative. You know, we could easily extend this to a larger number. But I'd say a good thing to take away from this exercise is this understanding how to restrict what a user can input, to constantly ask over and over again if the user doesn't put in what you want. Very, very important. So then what this individual has done is they've made a counted loop, and they've started their counter at 2, and then they go up to the number that's inputted divided by 2. So the reason why they do that is because if I have a number, say, let's take 42. 42 divided by 2 is going to be 21. So if I check 42 divided by 2 is 21, there's no need for me to check 42 divided by 21, which is equal to 2. So we only have to check the first half of the numbers, because they'll pair with other numbers to multiply to give me the result. And in fact, this isn't the most efficient way to do it. Actually, the most efficient number to put in here is to take the math.square root, take the square root of the number. And again, this is going to generate a double, so we need to tell the computer to make it an integer. And what that simply does, by putting int in front of it, is it says, take this double value, chop off the decimals. So then we say if num mod I is equivalent to 0. So we say the minute we find out that num mod I is equivalent to 0, we say it's not a prime, which makes perfect sense. So then what the student's done here, which is really nice, is they've incremented their counter to a number which is much larger than I could ever possibly be, thereby forcing the loop to exit. The problem that this student has with their code is this step here, is that they check if the num mod I is not equal to 0. And so think of it like this. Let's just pop this up here. If I have the number 43, so 43 mod 2 is equal to 1. So here's the thing. If I see this, I cannot say definitively that this is a prime yet. I can only say that it's not divisible by 2. However, if I have 44 and I do 44 mod 2 is equivalent to 0, we see that we failed this rule once. So therefore, as soon as if we find one number that divides our inputted number evenly, we can right away say it's not a prime and move on. So what we want to do here, one way to approach this problem is we don't need to check this inside the loop. But the problem is that, well, when do we output that it's a prime? Because if I run this now and I put in a number like 9, it tells me 9 is not a prime number. But if I put in a number like 11, it does nothing. So this actually works perfectly fine now, insofar as I can put in, say, 987, it's not a prime number. If I run and I put 101, which is a prime number, it gives me nothing. So I need now for the computer to remember whether this is prime or not. So we're going to introduce a new, we're going to make use of a Boolean variable. So I'm going to go up here, I'm going to make a Boolean variable called prime. And what this is going to do is it's going to store true if it is prime and false if not prime. So let's, for the sake of this discussion, the question we want to ask ourselves is, what do we initially assume the prime is going to be? And we can assume the prime, what do we assume the number is initially going to be? And so when I input a number, I initially assume that it is prime. So let's initially assume that this number is prime, right? Because the idea is that until I show that num mod I is equivalent to 0, I will think it's a prime. Oh, we need a semicolon there. There we go. So what I do now is I do the following. Is once we've proven that this is not a prime, we set prime to false. And then what I can do is I can go, this is the end of my for loop. I can go outside my for loop, and what I can actually do now is I can say if prime is equivalent to false, if prime is equivalent to true, we can do system.out.println this number, the number num is a prime. So what we're doing here is we're making use of this Boolean to help keep track of, I have an extra brace here, I think that's better. We're using this Boolean to help keep track if something is a prime or not. So sometimes in a program you want to have a variable that just remembers something, and that's what this Boolean does here. What it does is that when it gets here, it changes the Boolean, the prime Boolean, to false, so that after it's done all the checking, it knows whether or not to output. And in fact, one other way to do this is you could actually take this right out and let's paste this. And so let's do all our checking. Let's do an else. So what we can do now is we can not output anything in our loop, just simply keep track of if it's prime or not. And then once we're done doing all our algorithm, checking all those cases, then we can say if it's prime or not. So if I run this and I put in 101, 101 is not a prime. If I run this and I put in 102, 102 is not a prime. Let's put in another number like 43. 43 is a prime. 111. Whoop. Hit something here. Let's get rid of that. 1, 2, 3. So I hope this video has helped in helping you see how to think about this problem and how to make use of this Boolean variable to keep track of some piece of information until you want to output the result later on.